Hey students, this is a lecture on integrals involving inverse trigonometric functions. So make sure you've already watched my video on derivatives involving inverse trigonometric functions, because remember, integrals and derivatives are the same thing, only in reverse. So these formulas here are the only three formulas that we need to use, but notice there's no cosine inverse, there's no cotangent inverse, and there's also no cosecant inverse. We only have three formulas here for integrals. But the reason for that is if you look back at the formulas in your formula sheet for derivatives, remember sine inverse and cosine inverse, those derivatives only differed by a minus. Tan inverse and cotangent inverse also only differed by a minus. And then secant inverse and cosecant inverse also only differed by a minus. So for your integrals, if you look on your antiderivatives, aka integrals, there's only 3 of them that show up on your formula sheet instead of 6 of them, which hopefully makes sense because there's only really, these formulas are almost identical except for a minus. So it makes sense that there's only the need for 3 of them, the 3 different ones when you're doing integrals. So what we've got is the integral of 1 over the square root of a squared minus u squared du, the integral of 1 over a squared plus u squared du, and the integral of 1 over u times the square root of u squared minus a squared du. I don't know why it says dx there. It's supposed to say du. But if you get an integral in these forms and you can't integrate them any other way, you can use these 3 formulas. It turns out that the integral of this one is just sine inverse of u over a plus c. This one is 1 over a times tangent inverse of u over a plus c. And then this one ends up being 1 over a secant inverse of absolute value of u over a plus c. So they're very handy for some tricky integrals. Later on, we'll be learning about how to do integrals by trigonometric substitution, but that's sort of like the same idea as here, what we're doing here. It's just here we have inverse trigonometric functions. Okay, so let's go ahead and see these at work. I have all the formulas right here. So let's get started. Alright, so we're going to start with a relatively easy one. And the instructions on all these are evaluate the integral. Evaluate the integral. Okay, and for example number 1, we're going to be doing an indefinite integral. The integral of dx over the square root of 100 minus x squared. The integral of dx over the square root of 100 minus x squared. So now if you just try to integrate this the way it's written, if you try to do u substitution, it's not going to work. Because you would have to let u either be 100 minus x squared, and then you would have an extra x up here, or something like that. So if you try u substitution here, it's not going to work. U substitution doesn't work here. I don't want to take the time to actually write all that out, but it does not work on this problem. And as a result, this integral is pretty much impossible to do unless you either use a computer to calculate it numerically, or you use one of these new formulas. Okay, so looking at these formulas up here, the one that looks the most like this one would have to be the top one. Okay, so the integral of 1 over the square root of a squared minus u squared du equals sine inverse of u over a plus c. So I'm choosing that one because it has a square root of something minus something else squared. Okay, so instead of writing 100, remember that 10 times 10 is 100, so we can write that as 10 squared. So if we rewrite this in the form integral of dx over the square root of 10 squared minus x squared, then if we look at this formula, we can see that our a is actually going to be 10. Okay, so here our a is 10, and then our u, in this particular problem, our u is actually just x. Okay, so we actually have it in the form integral of 1 over square root of a squared minus u squared du. It's only here our a is 10 and our u is actually just x. Okay, so that's going to give us sine inverse of u over a plus c. Okay, so this equals sine inverse of u over a plus c. And we always write a plus c when it's an indefinite integral like this. And how do we know it's indefinite? Well, it's indefinite because it doesn't have any numbers that we're plugging in. Okay, so since we're not plugging in any numbers here, we just write a plus c at the end. Okay, and then we said our u is x, and then our a is 10. Okay, so this is going to be sine inverse of x over 10 plus c. And that's actually the whole problem. So an impossible integral becomes very easy if you just use this formula. Again, you're welcome to try it by u substitution, but unless you do something really tricky that I don't know about, I don't think you can do this by u substitution. However, the formula makes it very easy to calculate using sine inverse. Okay, so that's our first example. Let's take a look at another one. Now, unfortunately, they're not all going to be as easy as this first problem. Okay, so problem number 2 is the integral of 16 du over 36 plus 16 u squared. The integral of 16 du over 36 plus 16 u squared. All right. So now, this one isn't quite as easy as the last problem because it's not in a format where we can use it yet. But if we look at these formulas up here, the one that looks the most like ours would be the second one here. So the integral of 1 over a squared plus u squared, that's supposed to say du. This is supposed to say du. So this right here should be a du, and then this one is also a du. Okay, so the integral of 1 over a squared plus u squared du is actually 1 over a times tan inverse of u over a. In ours, we want to get it in this format, 1 over a squared plus u squared. So how are we going to do that? The standard thing here is you want to have a 1 over a squared plus u squared. So what you want to do is you need to factor out a 16. Okay, so factor that out. But how do you factor out a 16 on the bottom? Because this term doesn't have a 16 in it, right? 36 is 6 times 6, so it doesn't have a 16. Well, you just go ahead and factor out a 16 on the bottom, and then this one is going to be 36 over 16. Okay, so I know it looks a little bit strange, But if we factor out a 16 on the bottom, then that's the same as we have a 36 over 16 plus u squared. And then on the top, we have a 16 du. Now, why did I factor out that 16? Why did I have to do that? Well, I have to get it in the form of 1 over a squared plus u squared. Okay, and it wasn't in that form. So I couldn't use this formula yet. In order to use this formula, you can't have anything multiplied times your u squared. Okay, and if you factor out a 16 on the bottom, you're going to be left with 36 over 16 for this first term, because if you distribute that 16, the 16s are going to cancel and give you 36. Okay, so I know it looks a little bit strange, but that's the trick there. Okay, and then notice we have a 16 on the top and the bottom. So now these are going to cancel out. Okay, and then we've almost got it in the form we need it in. So now we've got the integral of du over 36 over 16 plus u squared. So remember, our goal is to get it in the form where it's 1 over a squared plus u squared du. So if I move the du over here, we're almost done. It's just this 36 over 16, this needs to be our a squared. Okay, so this here is going to be our a squared. Okay, so I know it's a little bit strange to get used to at first, but we have our a squared is going to be 36 over 16. And then if I take the square root of both sides, here, I'm going to get a equals, well, what's the square root of the top? Square root of 36 is 6. And then on the bottom, the square root of 16 is 4. And then if I simplify that a little bit, if I divide the top and the bottom by 2, I'm going to get a equals 3 over 2. Okay? Okay, so what we really have here is the integral of 1 over a squared plus u squared du, where a is actually equal to 3 over 2. And that was the hard part. Now the easy part is just using the formula. So notice I got it exactly in that form. So now we can just use the formula. The integral of 1 over a squared plus u squared du equals 1 over a tan inverse of u over a plus c. 1 over a tan inverse of u over a plus c. Okay, so here we have 1 over a tan inverse of u over a plus c. And again, we're going to write a plus c here because it's an indefinite integral. It doesn't have numbers to plug in. Now in this problem, the original variable was actually u. So we didn't even have to do any kind of substitution there. So we're just going to leave it in terms of u. However, we do need to plug back in what a was. So remember, we decided that a was 3/2. So instead of writing a here, we're going to go ahead and write 3/2 instead. Okay, but now that we got it in this form, it's pretty easy to use the formula. And remember, if you're dividing by a fraction, you flip it over and multiply on the top. So if we flip over these 3/2, they're going to become 2/3. Okay? And that's going to get us to our answer. Okay? So we're going to have a 2/3 tan inverse of 2/3 u plus c. And again, this is a strange problem because usually u is a dummy variable that you use in a u substitution or in one of the formulas. But in this particular problem, u is actually the original variable that we started with. Remember, the original variable was, we had a u squared down here and a du up there. So here we didn't end up using u as a dummy variable. So this is one of the few cases where your answer actually needs to be left in terms of u because that's the original variable in this problem. Okay, so that's a little important detail that you might not know. All right, so that right there is our answer to problem number 2. Okay, now these do get a little bit more tricky. That one had a bit of a trick to it, but hopefully it wasn't too bad. So let's take a look at problem number 3, or example number 3. So for example number 3, we're integrating dt over 7 plus the quantity t plus 7, quantity squared. Okay? So we have the integral of dt all over 7 plus parentheses t plus 7 squared. Now looking at the format here, this is already almost in the format that we need. The only thing that's strange is we have this t plus 7 quantity squared here. It actually has 2 terms instead of 1, but that's going to work out okay. So it's already in the form that we want it in. So it's already in the form, the integral of 1 over a squared plus u squared. So we just need to figure out what du is. And remember, in this problem, the original variable is t, but here we're actually going to be doing a u substitution of sorts. So here our u, remember our goal here is we want to have it in the form, the integral of 1 over a squared plus u squared du. That's what we want. Okay, so here we can see that a is going to be, well, a squared is going to be 7, and then u squared is going to be t plus 7 squared. Okay, so this is our u squared. And of course, if our u squared is t plus 7 quantity squared, that means u is t plus 7. Okay, so u is going to equal t plus 7. And then if we take the derivative of both sides, we get du dt. Du dt is equal to 1. Because the derivative of the variable t is just 1. And the derivative of 7, because it's a constant, is 0. So du dt equals 1. And then if I multiply both sides by dt, here I actually get du equals dt. Okay? So since du equals dt, we can actually just go ahead and plug in du for dt in this problem. And then we've got what we want. So we've got it in the form integral of du over a squared plus u squared. The only thing that's a little strange here is a squared is actually 7. So what's that going to mean here? Well, if a squared equals 7, then what does a have to be? Well, taking the square root of both sides, we get that a equals the square root of 7. And you might think, well, couldn't it be the negative square root of 7 as well? Shouldn't it be plus minus root 7? It shouldn't, because a is always intended to be a positive number within the context of these problems. Okay, so that's why I'm not writing a plus minus. It's just going to be positive root 7. It's always a positive root. Okay, so it's in the form, the integral of 1 over a squared plus u squared. and we just replaced the dt with the du. Okay, the only thing that was tricky was a is actually the square root of 7. Okay, but this integral is still going to give us tan inverse. So going back up here to the formula, this is going to give us 1 over a tan inverse of u over a plus c. So let me zoom out a little bit. So this is going to give us 1 over a tan inverse of u over a plus c. Okay, and then here in this problem, a is the square root of 7, and u we said was actually this right here, which is t plus 7. Okay, so in this problem we're actually going to end up with 1 over the square root of 7 times tan inverse of, well, u we said was t plus 7, so that's going to be t plus 7 over the square root of 7 plus c. Okay, and my math lab is a little bit weird on this problem. For some reason, they get rid of this radical in this denominator, but they don't get rid of the radical inside of the tan inverse. I don't know why they did that. I don't think there's a good reason why they did that, but I'm just going to do it the way they did. So they went ahead and rationalized the 1 over root 7. So they multiply the top and the bottom by root 7. But they don't do that inside of the tangent, which is just a little bit strange. But I want to do it the way they do it on your homework. That way you can get the right answer and not be too stressed out. So we got to get it in the form that they write it in. Okay, so I'm just going to multiply the top and the bottom by root 7. So that gives me root 7 over 7 times tan inverse of the quantity t plus 7 over root 7 plus c. And that's actually how they write their final answer, so I'm going to leave it that way. For whatever reason, that's how they do it. Okay, so we've seen a couple examples of tan inverse. And then I wanted to see an example of one of the other functions. Okay, so we've seen a tan inverse, and a sine inverse. So why don't we go ahead and do a problem that involves a secant inverse. Okay, so this is going to be example number 4. For this example, we're doing the integral of dr all over the quantity 4r plus 9 times the square root of the quantity 4r plus 9 quantity squared minus 16. Okay, so we have the integral of dr all over 4r plus 9 times the square root of the quantity 4r plus 9 squared minus 16. So this one is mostly, it looks scary because it has so much going on. But if we look at our formulas, if we look at these 3 formulas here, we can see that the one it most looks like would be the third one. Okay, so the one involving secant inverse. So what we're going to have to do is we need to get it in the form integral of 1 over u times the square root of u squared minus a squared, and that's supposed to say du. Okay, so we want to have it in the form integral of 1 over u times the square root of u squared minus a squared du. That's our goal. Okay, that's the form that we need to get it in order to use the formula. And if you look at it, it's pretty close to that form. It's not exactly in that form though, because here our u is going to end up having to be a 4r plus 9. So our du is going to end up with an extra 4 in there. So we can't just leave it as dr on the top. So again, integral of 1 over u times the square root of u squared minus a squared du. That's what we're looking for, because that's the formula that it's closest to. So here hopefully you should be able to see that our u is going to have to be 4r plus 9. Because we've got a u there, and then we've got a u squared there. And then we can see that our a squared, let me use a different color for that one. We can see that our a squared is actually going to have to be 16. Okay, so a squared is going to have to be 16. Okay, and since u equals 4r plus 9, we're going to have to figure out an expression for dr in terms of du. So we do have to do that. Okay, so we're going to let u, I think I'm going to do this in green. So u equals 4r plus 9. And then our du dr, the derivative is just going to be 4. Right, because the derivative of 4r is just 4, and the derivative of 9 is 0 because it's a constant. And then if we isolate dr, multiply both sides by dr, divide both sides by 4, we get du over 4 equals dr. Okay, now we can go ahead and plug in this du over 4 and for the dr up here. Okay, so after we do that, we almost have the integral in the form it needs to be in. So we're going to have the integral of du over 4 over u times the square root of u squared minus a squared. So then we've already almost got it in the form it needs to be in. We just need to go ahead and factor the 1/4 out front, because that's a constant. And we can move the du over here, so it looks exactly the same. Okay, so if I bring the 1/4 out front, we're going to get 1/4 times the integral of 1 over u times the square root of u squared minus a squared du. Okay, and so we've got it in that form. We just need to figure out what a is. But as you can see, a squared is 16. So if you take the square root of 16, that should be 4. Okay, so here, a squared equals 16. So that means if we take the square root, a equals 4. And again, you don't want to have negative 4. You always want to have the positive square root when you're using these formulas. Okay? So we just have a 1/4 out front, but then the rest of it is just going to integrate according to the formula. So we're going to have 1 over a secant inverse of absolute value of u over a plus c. Okay. So we still have a 1/4 out front. That's the only thing that's different about this. So we have 1/4 times 1 over a secant inverse of absolute value of u over a plus c. And I wrote the 1/4 because remember we had factored out a 1/4. But this part here, that's that integral. And I'm just using the formula from your formula sheet. Okay, so that one is 1 over a secant inverse of u over a, absolute value around that, plus c. Okay, and then since we already know that a is 4, and we know that u is 4r plus 9, we can go ahead and plug those in. Okay, so we're going to be plugging in 4 in place of those a's, and then we're going to be plugging in 4r plus 9 in place of u. Okay, and of course we still have a 1/4 out front. Okay, so we have 1/4 times 1 over 4 secant inverse of absolute value of, well, we said u was 4r plus 9. So that's going to be 4r plus 9 all over 4 plus c. And the only thing that we need to do is we have to distribute the 1/4. So you might think after you distribute that 1/4, well, 1/4 times 1/4 is 1/16 secant inverse of absolute value of 4r plus 9 all over 4 plus 1/4 c. However, 1/4 c is still a constant, and c just means an arbitrary constant. So I know you might think that you would write your answer as 1/4 c, but instead of that, you can actually just write c. Oh my gosh, my son is really crying. So anyway, what I was saying is this is still a constant, still an arbitrary constant. So instead of writing 1/4 c, you just write c, because it's still a constant. Okay, so I know that's a little bit strange, because most people don't think of 1/4 c as being the same as c. But in this case it is, because c just represents any constant. So there's no need to write a 1/4 times a constant, because that's still any constant. It could be any number. Okay, so our answer is, instead of writing 1/4 c, we're going to go ahead and write plus c. So it's one of the few times in math where numbers just disappear because 1/4 c is still a constant, so that's still the same as c. Okay, and that's going to be our final answer. And come to think of it, all of your homework problems from this section are actually indefinite integrals. So they're all going to be plus c. But you can still use these formulas with definite integrals. We're just not doing it because they can be kind of a pain, because you have to plug them into the inverse trig function, and that can be a lot of extra work. So we're just going to be focusing on indefinite integrals. Okay, so I think I wanted to do one or two more. Now, there's one last trick from this section, which can make these problems a bit harder, particularly if you don't remember how to do it. Okay, so let me zoom back in here. I'm all zoomed out. Okay, so problem number 5. This one has a little bit of a challenge to it. So this one is the integral of dx all over the square root of negative x squared plus 14x minus 48. Okay, the integral of dx over the square root of negative x squared plus 14x minus 48. Now what's super tricky about this problem is, notice it's not already in one of the forms that we need it to be in. So if we look back at our formula sheet, it's not in any of these forms. So we either need to have it be this form, or this form. But if we look at it, it's not in any of those forms. But if we look at those forms, which one is the closest to this? Well, let's see. We have a square root on the bottom, and then we have a squared inside of the square root. So looking at these forms, I would say that it's closest to this first one. Now, it's not like the third one because we don't have a variable outside of the square root. So I would say that this is the one we want to use. Integral of 1 over the square root of a squared minus u squared du. So let's write that down as our goal, because that's the form that we're going to need to get it in to do this. So integral of 1 over the square root of a squared minus u squared du. And I just chose that one because it's the closest to this problem here. But obviously it's not in that form, which is going to make the problem a bit harder than the other ones. So the trick here is what you want to do is you actually want to complete the square. Now, how do you complete the square? Well, there's different ways different teachers teach it, and some of you might not remember how to complete the square. But the basic idea is you want to write it as something squared minus something else squared. And that's why completing the square is going to work so well here. Okay, so let's see how we do that. So we want our a squared minus u squared to become this. So we're going to complete the square. Complete the square. So we're going to start with this whole thing right here. We're going to start with the negative x squared plus 14x minus 48. Okay. And then to complete the square there, I don't know if you remember how to do it, but basically, first you just write down the problem. So you got negative x squared plus 14x minus 48. And then the standard thing is if you have a minus in front of the highest term, you want to actually factor out the minus for starters. So we factor out a minus from the whole thing, and we're going to be left with x squared minus 14x plus 48. Okay, and then what do you do next? Well, you want to rewrite it as, hold on, my recorder's messing up here. Okay, sorry, I was having technical issues with the recorder. Okay, so I think it's working again. So anyway, what I was saying is when you're completing the square, you want to group together the first two terms, so the first two highest powers. In fact, let me do that in a different color. So I'll put brackets around these two. Okay, and then what you want to do is you take the second term, so the term involving x, you divide by 2, and then you square it. Okay? Okay, so this is just in case you don't remember how to complete the square. Divide middle term by 2, then square it. Okay, so And by middle term, I mean middle coefficient. So what we've got here is we've got negative 14 for our middle coefficient. We divide that by 2. So that's going to give us negative 7. And then we square it. So if we do negative 7 squared, that gives us 49. Okay, and then what do you do with the 49? Well, you just go ahead and you add it, but then you also subtract it, which is, I know, a bit strange. Because normally when people are completing the square, they have an equation and they're adding something to both sides. But here, because we just have a single expression, we want to add 49 and then also subtract it. Okay? So we're going to add and subtract 49. And 49 is what we got when we took the middle term, we divided by 2, and then we squared it. Okay, so here we're going to have, we still have a minus out front. And then we've got the x squared minus 14x. And on the inside there, we want to add 49. Okay, so we're going to add 49. But then that's inside of those brackets. But then on the outside, we also have to subtract 49. We also have to subtract 49. Okay. All right, so completing the square, if you don't remember it, just remember what you're supposed to do is you take your middle term, you divide it by 2, then you square it, and then you add and subtract whatever you got. And here you want to add it on the inside and subtract it on the outside. But don't forget, we still have a plus 48 on the outside. So I almost forgot to write in my plus 48. So in blue there, I'm completing the square. And the reason it's called completing the square is then this bit right here, this part in brackets, is going to factor. Okay, and then on the outside here, we can go ahead and combine the negative 49 and the positive 48. So that's going to give us a negative 1 on the outside. Okay, so here we have a negative 1, and then how does this factor? Well, this is going to factor as x minus 7 quantity squared. So it factors as x minus 7 quantity squared. And then we still have a minus out front. Okay, and because we have this minus out front at the very end here, we can go ahead and distribute the minus. Okay, and that's going to give us negative of x minus 7 quantity squared plus 1, because the minus is going to cancel for the second term. And then we don't need these brackets anymore, so I'm going to replace these brackets with parentheses instead. So those are just the standard grouping symbol. Okay, so we actually get negative of the quantity x minus 7 quantity squared plus 1. Now I'm only going to do one example of this because it is a hard technique. And it took me a while to explain it, but if you remember how to complete this square already, then this part shouldn't be as hard. But it took me a while to explain it because it's been a while since I've done it myself. But now that we've got it in this format, this is almost in the format we need it to be in. So this entire thing right here that I circled in red, is now just the same as this. So it's negative of the quantity x minus 7 quantity squared plus 1. So I can go ahead and plug that into the original problem. Okay, so we have the integral of dx over the square root of negative quantity x minus 7 quantity squared plus 1 okay, and with that we are almost finished with the hard part, the new hard part, which was completing the square. So we have completed the square, but then we still need to get it in exactly this format. Okay, so we need to get in the format integral of 1 over the square root of a squared minus u squared du. So remember, a is going to be your constant, and u is actually going to be your variable. So if I switch the order around here, we've got the integral of 1 over the square root of 1 minus the quantity x minus 7 quantity squared dx. So it's almost in the format we need it to be in. It's just here our a squared is actually going to be 1. So 1 is our a squared. And then our u is going to have to be x minus 7. U is actually going to be x minus 7. Okay, but if we do u equals x minus 7, if u equals x minus 7, then du dx is actually going to equal 1, because the derivative of x minus 7 is going to be 1. And then, so that just means du equals dx. So we can go ahead and replace this dx with du instead. Okay, and then after we do all that, we finally got it in this format we want it to be in. Okay, so now we have the integral of 1 over the square root of a squared minus u squared du, because dx is just the same as du. Okay, and here a squared is going to be 1, and if you take the square root of 1, it's still 1. So since a squared equals 1, that means a is also going to equal 1. Okay, so here we actually have the integral of 1 over the square root of a squared minus u squared du. And so finally, after all of that work, we are ready to plug stuff into the formula. So looking at the formula, we're looking at this first formula, and this integral is going to become sine inverse of u over a plus c. Okay, sine inverse of u over a plus c. Oh my gosh, okay, there it goes. Sine inverse of u over a plus c. And then we just go ahead and plug in the u and the a that we had in this problem. So in this problem, u equals x minus 7. And then a, we said was 1. Since a squared was 1, the square root of 1 is 1. So here a is 1. So we have sine inverse of x minus 7 all over 1 plus c. But then, of course, any number divided by 1 is just 1. So that's going to get us to our final answer, which is going to be sine inverse of x minus 7 plus c. Okay, and then on your homework, you have one more problem that is similar to this one. It's just the format is more set up for a tan inverse rather than a sine inverse. But for that one, for the last problem in your homework, problem number 12, well, depending on your class, it might not be problem number 12. But there's one more problem where it's more in the format of tangent inverse. So it's more in this format here. But you're still going to complete the square. And if you complete the square there, you're going to find that you can get it in this format, 1 over a squared plus u squared du. And then that integral is going to give you this. So that's the trick for that one. I just don't want to do another example since we just did an example of completing the square. But, you know, for completing the square, you basically just, if your highest term has a minus, you factor out the minus, and then you take the middle term, divide it by 2, then you square it, you add that and subtract it, and then that makes it so you can factor. And once you can factor, then if you had a minus, you distribute it, but if you didn't have a minus, you don't distribute it. And then once you have it like that, these problems are set up so that after you complete the square, you can go ahead and write it in a format where you can use sine inverse or tangent inverse. So the other problem on your homework is going to be tangent inverse. And you're going to also complete the square with that one. Okay? Well, thanks for watching.